There's a concept called half-life, and I've given a definition of half-life here. So a half-life is the time it takes for half of an amount to disappear or go away or decay or somehow not be around anymore. So let's say, for example, we start with 1,000 things. After one half-life, half of them are gone. So now we have 500 left. After two half-lives, so we lost half, then we lost half again, there would be 250 left. So what we're doing is a half-life, we're essentially losing. It's a decay problem where we're losing 50%. So we're always losing half of it. After three half-lives, we're going to have 125 things left. After four half-lives, we're going to have 67 and a half things left. If you're talking about things that could be divided, so if it's grams, then you would have 67 and a half grams left. If it's things that are not divisible, like people, so let's say, for example, you have a crowd of 1,000, and the crowd seems to have a half-life of whatever. After one half-life, there's 500 people left in the crowd, 250 to 125. And then what this number usually means is that half the time there's about 67 people left, and the other half of the time there's 68 people left. We're not going to get into that too much. So that's what a half-life means. Okay. In the winter, the bees start to die because we only care about the queen. The half-life of the bee population in a given hive is 4 days after the onset of freezing. So what that means is every 4 days, half the population dies. If the hive started off with 7,000 bees, how many would be left after 20 days? Okay, so as usual, we're trying to figure out the final amount. The initial amount in this case was 7,000. The growth rate, a half-life means that we're losing half of them. So every time we have a half-life, I should have written it, it's minus 50%. I kind of jumped ahead, which is negative 0.5. And then the number of times that this happens is going to be the elapsed time over, what's the half-life? Over the half-life, right? It's going to be the elapsed time over kind of our half-life, which in this case is 5. So putting it all together, we would find out that A equals, so remember A equals A naught 1 plus G to the N. A equals A naught 1, we're losing half of them, and we're doing that 20 over 4 times. Or to put it another way, it's going to be 0.5 to the 20 over 4. Which we're going to actually calculate, which is 5, of course. I don't know why I didn't do that. And A naught in this case is 7,000. We should add that step in. Okay, that was a lot of unnecessary steps there. Hopefully you won't do so many unnecessary steps. I was feeling exuberant because of all the paper I had, presumably. So that times 7,000 is 218.75 bees. And since it's bees, we'll kind of round it off, which means that there will probably be around 219 bees left in the hive. What it means is that there's a 75% chance there'll be 219 and about a 20% chance that there'll be 25% chance there'll be 218. Okay, so we have all that. So what we're going to do, kind of like the other one, we're going to make a formula. So we're going to have a half-life formula. So that's our final amount, and then we have our initial amount. And what we're going to say is we're going to say that the final amount for a half-life is going to be A naught times 0.5, and the number of times this is going to happen is going to be the elapsed time over the half-life. And that's the half-life formula. There's a couple of different forms of this one. You can pick whichever one makes you happy. Another way of writing this would be a 1/2 to the t over h. That's another version of the half-life formula. A third version, I'm not going to I don't want to pollute this paper. A third version of that one would be by noticing, I don't know why I'm doing that, that 1/2 to the t over h is like 2 to the negative 1 to the t over h, which is equal to 2 to the minus t over h. So a third way of writing the half-life formula would be a equals a naught 2 to the minus t over h. And any one of those formulas works.